Today's companies implement a large variety of technologies in intralogistic processes. These technologies range from standard automation equipment to complex service robots. But in order to be worth the investment, automated solutions must work continuously, either through a constant stream of goods or the flexibility to perform other tasks. Additionally, modern intralogistic processes demand flexible technologies that can adapt to dynamic processes. Current automation solutions lack the necessary flexibility that is required in dynamic intralogistic environments. For example, while fully automated systems perform well in highly standardized environments, they only achieve cost efficiency if their capacity is continuously exploited. And once implemented, processes can hardly be changed without further investments and integration efforts. Even when full automation is implemented, human labor is still very much needed. Manual work still has the highest capability for flexibility. However, human labor has significant limitations. Repeated heavy work, traveling long distances, and lifting can lead to injuries, stress, or fatigue. And hourly work is costly, especially on night shifts, special days, or weekends. And because of the hard working conditions, the number of available people who are willing to work in logistics is decreasing. Between fully static automation and completely flexible manual work, service robots could be a solution to match performance with flexibility, as they are more suitable to perform different tasks and can work together with a human operator. Service robots favor scalability, as more units could be introduced to the system to achieve an overall higher system capacity. However, there are limits to the flexibility of robots. While they are suitable for different processes, reconfiguring a robot for a new task is not simple. They might need new technological modules and software, the purchase, testing, and implementation of which can be a costly and time-consuming process. And they are still slower than fully automated processes. And they are still less flexible and versatile than a human operator. Therefore, an ideal intralogistic solution finds the right combination of automation, service robots, and human labor as to compensate for their respective strengths and weaknesses. In practical situations, companies must fulfill orders by means of the available resources, all of which have different degrees of flexibility, levels of adaptability, economical viability, and quality criteria. To help make this process easier, key players from research and industry have worked together to create a toolkit. This toolkit can support various roles within the intralogistic sector. For example, logistics experts can use the evaluation tools to help determine which configurations are possible. These recommended variations can be compared using simulation tools and key performance indicators to identify the best option. Robotic system integrators can also use the toolkit to access already developed hardware and software components to assemble or customize the system. This reuse significantly reduces development time and costs. If changes in requirements occur, a logistics process engineer can use elements from the toolkit to change processes or remodel the environment without having to involve a robot system integrator. This toolkit solves many of the issues faced today in intralogistic planning. It allows faster implementation of intralogistic systems. It reduces investment costs through the reuse of building blocks of software and hardware. And because of easy customization, it amortizes the acquisition costs over a longer period of time, thus also lowering the investment hurdle.